Okay, my name is Woody Liu, and today I'm going to be talking about the desired properties of 316L. So, first of all, the desired properties means that like the specific characteristic that we want from 316L so it performs well in like real life situations. So, 316L is chosen because it stays strong, resists rust, and it stays tough like when it's cold. So, yeah, and it also we need its chemical properties to be specific like Cr, Ni, Mo, and low C, and also its structures. So we need it to be stable under most conditions. So for 316L, so for stuff like cooling rate, uh heat treatments and alloy like compositions, it affects like the stuff I just talked about, the strength, the corrosion resistance, and the toughness. Okay. So why does desired property matters? So 316L is used like in the environment where reliability and consistency is really important. So 316L is chosen for like really critical like situations like medical stuff, chemical stuff, and marine stuff. And so, first of all, like medical implants, chemical tanks, marine hardwares, and cryogenic systems. So, for example, engineers need to know like how strong the property is and how much it bends, like how much it behaves under force, and also we need it to stay tough even when it's cold, and we need it to be stable when it's heated. So for the key mechanical properties, and so for strength, it's like we need to have strength, toughness, ductability, fatigue resistance, and work hardening. So first of all, strength is from 170 to 310 MPa, so it can take a lot of loads. And for the toughness, we is from 100 to 200 J, which it can absorb a lot of like energy before breaking. And for ductability, so it's from 40% to 60% elongation. So that means basically just like it can stretch a lot. And for like FCC, Melo has a lot of subsystems, so they bend instead of snapping. And it also has a strong fatigue resistance, so it can survive like lots of loading, like pressure cycles without having like cracks and stuff. And it also has high work hardening capabilities, so like once you deform it, it becomes like stronger because the dislocation multiplies. Okay, so another important thing that a 316L has to have is the corrosion resistance, and it's basically one of the most corrosion resistant steels. And so okay, so chromium so how it works is that chromium reacts with oxygen to form Cr2O3, which is like a protective film, and it protects it from corrosion. And like pitting, like we there's pitting, which is tiny holes like from the chloride attacks, like from the chlorides being formed. And like this happens especially in like places where there's lots of chloride, like saltwater, beaches, and many chemicals like contain chlorides. And this makes it suitable for like marine chemical and biomedical like stuff. Um, so like stretch plus corrosion can cause sudden failure in like some steels, but 316L is exception because it has the strong corrosion resistance. Okay, so for the microstructure stability, so it is stable for the stable FCC authentic. So 316L stay in the FCC phase at room temperature, which gives the toughness and ductability. And harmful phase like sigma, like carbide, reduces toughness and corrosion resistance. And so f- like microstructure also avoids transformation during services. And so another thing you have to remember that sigma is brittle and carbide like is steals chromium from passive films, like what I just talked about earlier about um the corrosives. Okay. So faceability considerations. So maintaining like a structure at room temperature is essential. So long exposure from like 600 Celsius to 900 Celsius can cause sigma phases, and carbides can form if the carbon level is too high. And okay, and maintaining face stability ensure that the alloy retains its mechanical and chemical performance. Okay, so the magnetic property, basically all you have to know is that 316L is non-magnetic, and so like MRI, so for example, MRI machines uses strong magnets, and magnets like materials are dangerous, so which is like dangerous for 316L, so that's what we don't want. And so sensors and electronic can malfunction if the metal is magnetic, and that's another bad thing. So like its low magnetic permit its low magnetic characteristics can ensure that it has like a predictable behavior, so it doesn't like cause this machine to malfunction. Okay, for the chemical compositions, so chromium, which is the corrosion resistance, CR, like I said before, forms the passive film Cr2O3, which prevents the rust from coming in. And we have also like we have nickel, which is stabilizes like the structure and keeps the FCC structure stable at room temperature. And then we have MO, and which improves the pitting resistance, like just like chromium, which I go against the chloride attacks. And then we have carbon, which prevents the carbon precipitations. So low carbon keeps the chromium available for corrosion resistance. And lastly, we have iron, which is Fe, which is the base metal. And Fe makes up most of the alloys and provides like the general structures for the whole entire composition. And yeah, that is it.